Hello, everyone. I'm Substack. I'm here to talk to you about this weird old thing called progressive enhancement and why you might even care or not. So the biggest reason why you should care is that when you load a page, you see content, but if all of your application is being fetched with just purely client-side JavaScript, you're gonna like stare at a little spinny little icon-y thing, or perhaps you'll just see a blank page and then XHR round trip happens, and then maybe eventually you'll see your content. It's kind of a lousy, it's not only a lousy experience in some cases, but it's also not very accessible. So people with screen readers, or people who like have their fonts all zoomed up because they can't see very well, it's not so great for that. And it's also, of course, search engine friendly. And you might not care about that especially much, but it's quite annoying. Like, for instance, my old blog on Substack.net was just doing purely client-side fetches to fetch all of the content. But whenever I would share a link, like on Twitter or something, the shortener would show a description that was just from my About page, because the content was not being rendered in the way that all of the technology of the internet expects it to be rendered. So, and what's really great about this approach is you can just view source and view your source. You don't have to like use a complicated debugger. You could just use curl or view source or what have you for this kind of stuff. It's really simple, it's really great. So why isn't everyone doing this? Well, it's really super freaking hard, that's why. But I've made some weird old tips that might be able to help you out. So let's just dive right into those. Okay, so the first thing, well, N2 and tail dash N1. The first thing is trumpet. So that's what we can look at first. So, so trumpet is this module that lets you stream HTML and do transformations on it. So why would you want to do that? Well, for doing this kind of progressive enhancement, you've got to be quite careful about how you structure your code. So things like templates really are quite a bit harder to get working, and I found that just doing regular HTML made it much easier. So bear with me for a moment as we delve into Trumpet a little bit. So basically, you have some HTML, right? Here's some HTML. Maybe we have like a placeholder value for the title. We have an h1 tag with an ID in it. With Trumpet, you first of all require Trumpet. Then you make a new Trumpet instance, and that returns a duplex stream. And so you write data from like a HTML file into that duplex stream, which is tr in this case. And then the tr instance emits data that is like the transform stream. So it's like input comes in from like regular HTML, you do some transformations in the middle on the instance, and then HTML comes out the other side that's been transformed. So what do transforms look like? Here they go. So you can use CSS selectors with Trumpet. So for instance here, we're selecting the XYZ ID, which is the H1 from the previous HTML example. And what's really cool is when you select a CSS element, you can call create write stream, and that itself is a stream that you can write into. So you can take streams and pipe them into your HTML, and then pipe them out again, which makes all of the plumbing for doing this progressive enhancement stuff quite pleasant, actually. So in this example, we've just got a write stream. So if I run this, cool. So remember before, in our HTML, which was 005, we had just XYZ with this empty content in here. And now we get the string beep boop. So we piped a stream into our HTML, which streamed to standard out. Great, that works. You can also set attributes if you like. So here we can set the class to robot on our beep boop h1 with the ID XYZ. So if I run that example, we get class robot. Cool. We can also do things like create a stream for the title. So any kind of CSS selector will work, so including like funky stuff with attributes. So if we run that, we get the title text set to title text, just as we've expected. Cool. So suppose we have some HTML like this that you might see on like a stub of a real web page. And in this case, we have an ID robots. And then perhaps we have some robot HTML fragments like this, just a class robot and a name and a description. Simple stuff. So with Trumpet, you can require all the libraries you need, and then pipe the container HTML file, which is in this case is robot.html, into another write stream. So here we've created a container, and we're piping the fragments into the container. And so all you have to do is pipe up your container HTML into the sub HTML and then let it loose. So if I run this example, we can see robots in our HTML. So we took the original content that had div ID robots in it, and we put a robot in it. So this is like the basic way that just using Trumpet natively, you can embed like fragments of HTML with dynamic content into a superstructure of HTML. That's like the page that a designer might, well, the designer could put both of them together, and it's just all straight up HTML. Because templating with this kind of approach is quite a bit harder, so I haven't gotten around to that. So the next part is hyperglue. So hyperglue is a bit higher level abstraction on top of CSS selectors and on top of Trumpet. So the thing about progressive enhancement is you want to make sure that all of your code that you write works both in the client and in the server. And so to do that, you need to like shim out some abstractions to make everything work well. So here's hyperglue. Basically, you map keys, which are CSS selectors, to content and attributes. It's pretty simple. So, and of course, it works in Node in the browser. In Node, it uses Trumpet, and in the browser, it uses document.querySelector. So here we've got another example of some HTML. This is just an article with a title text. It's like the standard kind of thing that you might see in a blog. And we can write a hyperglue example with FS, and we can read file sync that article that I just showed, and console.log. So here we're mapping CSS selectors as the keys, like a title link with a href, which is an attribute, and some text, like glue. All programming is just glue code. And the body, true facts, of course, author Substack. So, and here we're doing a .outer HTML, which, so it kind of looks like a DOM element. Of course, it's not, because we can just run it in Node, and we get this output. So here it just did all of the replacements like you might expect. But the cool thing is we can run this code in the browser with Browserify. So if I do that, oh, hang on. I don't know why that worked. If you compile this code with brfs, it takes the fs.readFileSync call and it turns that into an inline string. So you can do fs.readFileSync in your browser code. And if we open that in a browser, then in the console, yes, we get the same text output that we got in Node. It's the same in both places, this kind of mystical holy grail of JavaScript on the server and in the browser and all kinds of crazy places in between. Great. So another cool thing you can do with hyperglue is you can document.body.appendChild that node instead of doing the .outer HTML. So this also works. Instead of printing with console.log, we can take this example and like render it to the browser. Uh-oh. Oh, yes. Browser.js. That's what it's called. Cool. So if we open that, we get the actual content in the page. Hooray! So that's the basics of hyperglue. There's not very much to it. The main point of it is that you can write simple stuff that's just a step above doing DOM element manipulation yourself. And it works in Node in the browser. So on top of this abstraction, too many hypermodules. Okay, on top of this abstraction, we can use this other one called the hyperspace. So hyperspace is the idea of hyperglue, but also merging it with Trumpet so that you can stream your HTML. So what does that look like? So previously, on progressive enhancement, this very talk, we saw this example. So this is just the article with the title and body and whatever. And here's what our hyperglue example code looked like, where we had a console log and we mapped some keys and whatever. So if we want to make that into a hyperstream example, or hyperspace example, it's super easy. So, so here is hyperglue, here's hyperspace. It's basically, you just change a couple of requires. And instead of getting back a string, you get back a stream. And so HS here, in this case, is a stream. And you can write to it. So you give hyperspace a callback, and when you write to it, this function fires. So we're just mapping exactly the same as in hyperglue, but with streams. Hooray. So instead of like static content, of course, you would want to put procedural content in there, like row.href and row.title and row.author, that kind of thing. And when you write to that stream, you will get oh, well, I have to pipe actually to standard out first, of course. There we go. So once you've piped that output to somewhere, then hooray, we're using streams now, and we're using the same basic approach as hyperglue. And, of course, this works in both Node and the browser. So we can, of course, the nice thing about this approach is you can have many documents that you want to render, and then you just pipe it into wherever it needs to go. So if I run that example, then we get more than one article in our article stream. Cool. So suppose we have a super sweet blog with the div ID articles in it, and we can write some rendering logic that just dumps it into HTML like this. So here we're doing, we're just using this article.html as the container, and from there, so you basically just write elements. I'm not actually sure what I was thinking here. Okay, here we go. Yeah, so you can use Trumpet for this example to insert into the container page. So you write a container page like an index.html, you put a div ID articles in it, and you hyperspace it into the page with all of your nested content. Oh yeah, so if I run this example, I think that's what yes. Cool, so there's HTML. See, we've got our decoration around it, so we've got our HTML head, title, body, and then in the articles, we've got all of our hyperspace content, which is cool. So let's do that, except in the browser. So if I skip ahead, it's exactly the same, except instead of calling .pipe to process.standardout, we can call .append to and give it a DOM node. And so then the cool thing about this is we get an element event that we can listen on. So if you want to register things like click handlers, you can just do that in the event callback. And what's really cool is hyperspace will do a query selector when you call append to with articles, so that all of the existing articles that the server rendered, the element handler will also fire for. So you can basically just put all of your handlers into one place, like all of your click handlers, and that will render, or that all of those click event listeners will be registered for the server side, and things that appear later over WebSockets and things. So if we run this example, browserify-tbrfs 160 browser static bundle.js, and then we open that. With static index.html. Okay, so cool. Well, now we've got two articles in our hyperstream. That's pretty sweet. But now suppose we've got another renderer that's like rendering articles, and we want to render glue code for that on both the client and the server. So this is browser code, and I don't actually recall what was special about this one. I think I should just skip past this. Okay. Anyways, hyperspace, you basically do a hyperglue, but you get a stream back. So the next thing is hyperkey. So hyperkey lets you, it's basically like hyperspace, but it gives you live updates. So all that you need to do to use it is have a key value store. So you give hyperkey objects with key and a value property, and then it figures everything out. So here we've got a message HTML fragment like before. We can just require a hyperkey and load the HTML content. Then we can do one of these like hyperglue style callbacks. And in our HTTP server, you can, after you've set up like a database and things, you can just have a start and an end key and take like a LevelDB read stream and just pipe that directly into your render function. So here we just require the render function, and this render function will be run server-side and browser-side. And we can select a div ID, in this case messages. And the thing that you need to do with hyperkey is you need to tell it a start and an end key in the markup, so that browser-side it knows what to listen for on the server. So it opens up a WebSocket connection and it tracks different key ranges. But once you've done that, it's all automatic. So you do this little bit. You can create a write stream, like just with Trumpet, back into your HTML. And once you've done all of that, with some like container markup like this, just like div ID messages kind of thing, then once you've done all of this, you can, well, first we'll put some data in the database. So here we've just got some users like Substack, T-Rex, and Robot, and some words, and we can just create a little function that'll push like spammy data to our database. So once we've done all of that, we can, okay, so once we've done all of that, we can run our server, and on localhost 5000, we get messages. Oh, hang on, I need to browserify something or another. Anyways, so we're going to just hop into the last example. So LevelDB is kind of tricky to use sometimes. I've got this module called Assoc that lets you do more relational data types, or more relations among your data. So I've also got a library called RenderAssoc that plugs into hyperkey for doing this kind of stuff. So if we create a LevelDB and we hook that up to LevelAssoc, you can do assoc.add, a collection name, and then you can specify things like has many, like a hackerspace, for instance, has many hackers and it has many tools. And all you need to do, you don't need to change your data at all. You just need to tell the document what the foreign keys are. Once you've done all of that, we can just take some data, throw that into our database, and populate it so that you can like create a new hacker and all of this kind of stuff. Anyways, so our server code then just becomes, there we go. So in our server code, we can just require our renderer function and set the start and end keys. And once we've done that, in our rendering code, blarg. So, right, you can use Trumpet to set up selectors and things. So once we've done all of that I just completely skipped past, we can actually run this thing. So if we start up our server, and then we can curl to localhost 5000, and we'll get the content rendered for us on the terminal. And then to make this work in the browser, we can just set up a WebSocket. Here I'm using Shoe, and I'm piping to assoc.track, which sets up a tracker for us. And our browser code then just looks like this. So that's all. You can use the the RenderAssoc module to set up some associations. And once you've done all of that, You can browserify it. So browserify -tbrfs 760 browser, and we'll put that static bundle. Then we can run the server and go to localhost. Uh-oh. Ah. What's that? Yeah, I don't know. A 620? Okay. Ah, thank you. Very, very good. Okay, so with that small amount of code that I kind of glossed over, here we've got, we can view source, right? So this is the initial content. If we refresh it, we'll get the freshest content. And once the page loads, the data keeps updating. So there are new entries being added at the bottom. There's like entries in the middle. We can kind of zoom out to see the data being updated live with a very, very small amount of code. The cool thing too is that once we've got all of this machinery set up, you can like just use curl. You can get this progressive enhancement stuff, and it's only about 5 extra lines to go from just one page to to a single page. But that's the last example. Let me skip ahead to that. So once we've got everything running, 860. There we go. So you can go from the same page, like doing a complete list of all of your documents, into doing like just a single document. Anyways, that's basically progressive enhancement. So the code for this will be on GitHub, and it'll probably be much less confusing when you look at it. So thank you.